I'm going to talk about how to evaluate the 6 trig functions for angles in quadrants 2, 3, and 4 that have a known reference angle. So we're going to evaluate the 6 trig functions for theta equal to 5 pi over 6. So 2 things I like to do when I'm doing this. Thing 1, theta is in quadrant 2. Because I know my angle is a little bit less than pi. And then 2, I know my reference angle is pi over 6. I know that in quadrant 2, sine is positive, right? All students take calculus. Sine is positive in quadrant 2. And that means sine is positive, as is its reciprocal cosecant. And then tangent and cosine are negative in quadrant 2, as are their reciprocals, cotangent and secant. So now I just have to think about what I know about pi over 6. So I know that sine of pi over 6 is 1/2. So I know that sine of pi over 6 is 1/2. I know cosine of pi over 6 is root 3 over 2. I know tangent of pi over 6 is 1 over root 3, which is root 3 over 3. But then I'm going to fix the sign. So I'm going to think about doing it for pi over 6, but I'm actually going to write 5 pi over 6. So I'm going to say sine of 5 pi over 6. I'm really thinking pi over 6 is 1/2. And then cosecant of 5 pi over 6, or pi over 6, is the reciprocal, just 2. And I'm leaving a little space in front because I'll show you in a sec. Cosine of 5 pi over 6, I'm going to write the wrong thing and say it's just root 3 over 2. And then tangent of 5 pi over 6 is sine over cosine, which is 1/2 over root 3 over 2. The 2's cancel, you get 1 over root 3, which is root 3 over 3. Similarly, secant of 5 pi over 6 is going to be 2 over root 3, which rationalizes as 2 root 3 over 3. And finally, cotangent of 5 pi over 6 is going to be something like 3 over root 3, which is just root 3. You can also say it's cosine over sine, root 3 over 2 over 1/2, the 2's cancel, and you just get root 3 over 1, which is root 3. Now, these aren't quite right, because the signs aren't right. Sine is positive, I know the SIGNs aren't right, the signs aren't right. Sine is right. Sine is positive, as is cosecant, because we're in quadrant 2. But cosine, tangent, and the reciprocal should be negative. So cosine of 5 pi over 6 should be negative root 3 over 2. Tangent of 5 pi over 6 should be negative root 3 over 3. Secant of 5 pi over 6 should be negative 2 root 3 over 3. And cosine of 5 pi over 6 should be negative root 3. So typically I use the reference angle to find the values, right? I know that sine of pi over 6 is 1/2, cosine of pi over 6 is root 3 over 2, etc. And then I use the quadrant the reference angle is in to determine whether it's positive or negative. Let's do the same thing for the next angle, which is 7 pi over 4. So 7 pi over 4 is in quadrant 4, right? We have pi over 4 in quadrant 1, 2, 3 pi over 4 in quadrant 2, 5 pi over 4 in quadrant 3, and 7 pi over 4 in quadrant 4. So quadrant 4, we know that cosine is positive in quadrant 4, and sine and tangent are negative. And we know that our reference angle is just pi over 4. Pi over 4 is my favorite, well, not my favorite, but it's the one that's nice because we know that sine and cosine are the same. So I know that sine of pi over 4 is root 2 over 2, and cosine of pi over 4 is also root 2 over 2. And tangent of pi over 4 is 1 because it's sine over cosine, which is the same thing. So here's what I'm going to write, even though it's not exactly correct. I'm going to write sine of 7 pi over 4 is root 2 over 2. And cosine of 7 pi over 4 is root 2 over 2. And tangent of pi over 4 is sine over cosine, which is 1. And then I'm going to adjust the SIGNs, the signs. So sine is negative because we're in quadrant 4. Cosine is positive because we're in quadrant 4. And tangent you can say is negative because we're in quadrant 4, or because sine divided by cosine and then negative divided by positive is a negative. Then we do the reciprocals. So now we can just look at these and say, well, cosecant of 7 pi over 4. So it's kind of nice to think of sine as 1 over root 2, so that the reciprocal is root 2 over 1, or just root 2. So So cosecant of 7 pi over 4 is negative root 2. Secant of 7 pi over 4 is positive root 2. You don't need to write the positive sign. And cotangent of pi over 4, 7 pi over 4, is negative 1, because 1 over negative 1 is still negative 1. Important fact, reciprocals never change signs, right? If something is negative, its reciprocal is negative. If something is positive, its reciprocal is always positive. Right, so now I want you guys to try finding all 6 trig functions for the angle. Let's do 4 pi over 3. So I want you guys to all try that. So hopefully you've all given that a try. And now we can go ahead and figure out what the answers are. So sine of 4 pi over 3. Well, I know that sine of pi over 3 is a reference angle. Sine of pi over 3 is root 3 over 2. Pi over 3 is in quadrant 3, so sine of 4 pi over 3 should be negative root 3 over 2. If sine is root 3 over 2, I know cosine is 1/2. So sine of 4 pi over 3 is negative root 3 over 2. Cosine of 4 pi over 3 is negative 1/2. Again, because in quadrant 3, tangent's positive and the other two are negative. And then finally, tangent of 4 pi over 3 is going to be root 3 over 1, which is just root 3, and it will be positive. Again, I'm thinking of it as sine over cosine. The 2's cancel, you get root 3 over 1. Cosecant, secant, and cotangent are just the reciprocals. So the reciprocal of negative root 3 over 2 is negative 2 over root 3, and then we rationalize and get negative 2 root 3 over 3. The reciprocal of negative 1/2 is negative 2. The reciprocal of root 3 is 1 over root 3, which rationalizes as root 3.